We are making quick progress through the cross-cutting concerns chapter, and in this lesson we will be talking about distributed caching, and we are going to use Redis as our distributed cache. Caching is one of those cross-cutting concerns that's very valuable in terms of improving performance in your application. You can store frequently accessed values inside of a cache, which could be in memory, or a distributed cache like Redis, and this will spare you from having to execute an expensive database request in favor of fetching some value from the cache. This could also be valuable for sharing data across your modules, for example, storing the permissions that are needed for authorization for the current user. Now, how are we going to implement caching? I will start by defining an abstraction for caching inside of the application layer. So let me create a caching folder, and then I'm going to add an interface inside that will be called iCacheService. In order to implement an effective cache, we really only need 3 methods. We're going to need one method that will be a generic method returning some result object that we can call getAsync. This method is going to give us back a value by a specific key, and I can also pass in an optional cancellation token. Then we're going to need another method that's going to set a particular value inside of the cache, and let's call this setAsync. This method is going to need a few more arguments. So it's going to need the key to which we want to set the value. Then it's going to need the value object that we want to set inside of the cache, and we will need to take care of serializing this object somehow, either into a JSON string or serializing it into bytes and then persisting that inside of the cache. And it's also very practical to add an expiration for the value that you are caching, otherwise you might end up overloading your cache, in which case most cache implementations have an eviction policy and some of the existing key value pairs will be evicted from the cache in favor of storing the new one. One more method that's valuable to have on this interface is a removeAsync method that's just going to clear a value with a particular key from the cache. I'm also going to add a cancellation token as an optional argument. Because we defined this interface inside of the application layer, it's going to be available to our use cases to use caching however they prefer. Now, the implementation of this is going to live in the infrastructure project. So let me add a caching folder. Because this is a cross-cutting concern, I can implement it once and reuse it in all of my modules. I'm going to add 2 files inside, a cache options file, which you can find under this video, as well as the cache service file, which you can also find under this video. The cache options is just going to define a default expiration time for our cache values, and I picked a default expiration of 2 minutes. Otherwise, you can pass in a custom expiration time if you prefer to set your own value. And in the cache service implementation, we're going to implement our cache service interface, obviously, but the question is, how are we going to do it? I'm leveraging the iDistributed Cache interface, which is available in Microsoft Extensions Caching Distributed, and I'm using this interface because it's very flexible. It has both an in-memory implementation that you can run inside of ASP.NET Core, and it also has an implementation that can integrate with Redis. The method implementations are fairly straightforward. We're going to use the respective methods available on the iDistributed Cache to implement our own cache methods. In the getAsync method, we are fetching a value by the given key. Now this interface returns bytes by default, and it also works with bytes when storing values, so we will have to take care of deserializing this into our object and then serializing the value into bytes when we are setting the cache key. To deserialize and serialize values, I'm using the default JSON serializer. We also need to register this with dependency injection, so let's head over to the infrastructure configuration class, and inside of the add infrastructure method, I'm going to say services try add singleton, and I want to add my iCacheService as a singleton implementation of the iCacheService interface. I also mentioned that we want to use Redis as a distributed cache inside of our system, so let's add a NuGet package that's going to allow us to talk with Redis. I'm going to look for Redis, and the NuGet package that I want to install is Microsoft Extensions Caching Stack Exchange Redis. This contains a distributed cache implementation for the iDistributed Cache interface. So let's go ahead and install the latest version, and let's head back to our infrastructure configuration class. We are going to need a connection string for Redis, so I'm going to add that as another argument, It's just going to be a string value that I'm going to pull in my program file. And then I'm going to add a few lines of code. First, I want to create a new iConnection multiplexer. This is a connection to our Redis interface, and this type is available in the Stack Exchange Redis namespace. Let's call this the connection multiplexer. We're going to create this from the connection multiplexer type, and we can call the connect method and pass in the Redis connection string. I'm doing this because I want to register this type as a singleton, because this interface will be resolved internally by some services that we will be using, and then I need to add my Stack Exchange Redis services by calling add Stack Exchange Redis cache. This method accepts a delegate working with the Redis cache options, and you have two ways how you can connect to your Redis instance. You can set the connection string on the configuration property, or you can set the connection multiplexer factory, which is what I'm going to do, and we need to provide a delegate that's going to return this value asynchronously. Now I'm going to say return task from result and just take the existing connection multiplexer value that I already have. The next thing we need to do is, of course, to add Redis as a Docker container. I'm going to add a code snippet that's going to create a Redis container. We will use the latest Redis image, and we can expose Redis on the default port of 6379. You can grab this code snippet under this video. Now I'm going to define a connection string that we can use to connect to our Redis instance. And let's do that inside of the app settings JSON file. Let's call this connection string a cache, and I will leave this empty in my app settings JSON. I will set the actual value inside of my app settings development JSON. And this connection string will point to my Redis instance running inside of a Docker container. The host used here, Evently Redis, is the name of my Docker container. And we are also using the internal port of our Redis instance. The only thing that's left is to pass our connection string from our program file. So we are already passing the connection string for our database. Let's do the same for our cache. And now let's see if our caching is actually working with a quick demo. I will head over to the get categories endpoint, and I'm going to implement the cache aside pattern very quickly. I want to add the iCache service from the request delegate, and then I want to say await cache service, let's say get async, and I'm going to copy the response of my result object, which is actually the result of the query. The cache key, let's say it's something like categories. I'm just going to hard code that. And let's introduce a variable that's going to contain the category responses. If this value isn't null, so if category responses is not null, then we can say return results.ok and pass in the category responses. So if we have a cache hit, we can return this value. Otherwise, let's execute our request, which is going to hit the database. And then if the result object is a success object, we're going to set the value in the cache before returning from our endpoint. So I'm going to say cache service set async. Let's use the same cache key, and I can pass in the value from the result object. And now let's give this a try. If I open up Docker desktop, you can see that my Redis container is running as part of my Docker Compose setup. And if I go over into Postman, I'm going to send a GET request to our endpoint to fetch all of the categories. This will hit the breakpoint that I added, and we're going to check if we have the value present in the cache, which isn't the case because we don't have anything in the cache yet. So let's execute our query, and if this is a success result, which it is, let's set the respective value in the cache and return from this endpoint. So you can see that we get the result back. Now if I send the same request again, we're going to first check if the value is present in the cache, and because it is, we're going to directly return from this endpoint without querying the database. And you can see that we get the response back in Postman. So this was a quick demo of the cache aside pattern using our cache service abstraction that was connecting to Redis. Now I won't be including this as part of the final source code, so I just wanted to mention that as we wrap up this lesson. In this lesson, we talked about distributed caching as a cross-cutting concern. I showed you how to implement a simple cache service that leverages the iDistributed cache abstraction, which we can easily connect to our Redis distributed cache using the Stack Exchange Redis library. And now we have the ability to use the cache service inside of all of our modules. In the next lesson, we will be talking about health checks.